All right, welcome back. So let's do the final section for lesson number 6, and this is factoring completely. So the goal is, from now on, anytime you factor, always, no matter what, factor out a GCF if possible. Okay, factor out a GCF if possible, right? What's the reason for that? So let's take a look at this. Is there a GCF within this that we could factor? And notice that the GCF for this is 2. So if I were to factor out a 2, remember, what am I going to do with that 2? I divide this by 2, I divide this by 2, I divide this by 2, and I divide this by 2. And then what happens when I divide each of these by 2? I get x squared minus 8x plus 15. But then the idea is, notice that, you see how we factored one time? Can you factor this again? And that's the idea of factoring completely. Can you factor this again? What two numbers when you multiply give you 15, but when you add give you negative 8? Pause the video and try and figure it out. But it should be this. Because what's negative 5 times negative 3? It's 15. And what's negative 5 plus negative 3? It's negative 8. And you see how we factored one time, then we ask ourselves, can we factor again? And we could factor a second time. And that's what I want you to try and do for the other questions over here. Is, remember, this rule will always happen when it comes to factoring. Anytime you factor, you always, no matter what, factor out a greatest common factor if possible. Sometimes it's not possible, okay? So, yeah, here, is it possible to factor out something here? Try and do this one by yourself, okay? So let's see. What can I factor out of this one? I could factor out a 3, because 3 is the greatest common factor of 3, 15, and 42. And if I divide each of these by 3, I get x squared plus 5x minus 14, right? Because 3 times minus 14 is negative 42. And then can you factor this again? Pause the video and try and factor this. Right? How does it factor? It should be this. Okay, because 7 times negative 2 is negative 14. 7 minus 2 is 5. Okay, try and do the next one by yourself. Here, for this one, notice what's the greatest common factor. If I look at the 5, the 30, and the 40, what's the greatest common factor of that is 5. And then what about the x cubed, x squared, and x? Remember that the greatest common factor of these 3 is just x, okay? And this was from before. Just to recap, why is the greatest common factor of x cubed, x squared, and x is x? Because here, if I have this x cubed, it's equal to x times x times x. This x squared is equal to x times x. This x is equal to just x. How many x's do they all share in common? They all share one x in common. So notice that that's why we just have x as the greatest common factor of these 3. And then what am I going to do with that x? I'm going to divide each of these by 5x, right? And then whatever I get for the quotient comes over here. So here, 5 divided by 5 is 1. X to the 3 divided by x is x squared. 30 divided by 5 is 6. X squared divided by x is x. 40 divided by 5 is 8. X divided by x is 1. And remember, like 1 times 8 is just 8, right? So notice that we factored this one time. Can we factor it again? We can. This will just be x plus 4, x plus 2. Okay. Now let's take a look at this one. Here, always have your ax squared plus bx plus c have A be positive. Okay? Have A be positive. So what do I mean by A? Like here, what is the A value? It's not 1. Your A is -1. So what you're allowed to do is try and make this positive. What you could factor out is a -1. So notice that if you factor out -1, what does this whole thing become? It just becomes x squared minus 8x plus 15. Notice how the sign for each of these just changed. Okay? Because before, you couldn't factor this. Like, what two numbers when you multiply give you -15, but when you add give you 8? It's not possible. But now you can factor it. So you could just say x minus 5, x minus 3, just like that. And notice that this factors one time, then factors a second time. So the idea is you could take out that negative. And you see, I don't need to write -1, I just write the negative symbol. Okay? Last one over here. Okay, how do we do this one? Let's see. What is the greatest common factor of 27 and 12? It should be 3. Okay? And what's the greatest common factor of x cubed and x is just x. Okay? So then I'm going to divide this by 27 divided by 3 is 9. This is x squared. And this should be -4. Okay? Pause the video and try and see if you need to re-see that. Okay? Because that was a little fast. But then can I factor again? Notice that this is a difference of perfect squares. And how do you factor a difference of perfect squares? This just becomes 3x minus 2, 3x plus 2. Okay? That this is equal to that. Okay, I hope this video helped. This is the end of the factoring techniques. What I want you to do is do the homework and practice. I'll see you in class.